Hi students. In this session we are going to discuss about field effect transistor, that is FET. The first class we discussed about basic types of transistor. Actually transistor are classified into two types. What are the? BJT and UJT. What is BJT? Bipolar junction transistor. Here the working is based on both electrons and holes. That's why it is called bipolar junction transistor. There is unipolar junction transistor. The working is based on either holes or electrons. So under junction transistor, we are going to discuss about field effect transistor. Okay, fine. Like the same way BJT is classified into NPN and PNP, the same way FET field effect transistors are classified into N channel and P channel. This is a symbol of N channel FET and P channel FET. Okay, see here the arrow mark only differentiate the types of FET, whether it is N channel or P channel in the symbol. This is a symbol for field effect transistor. In N channel FET, it's towards the arrow, it's this side. In a P channel, the arrow is in outward side. So while I explain about working, you people know the reason why these arrows look like this. Okay. Next, we are going to discuss about the construction of field effect transistor. How we construct a field effect transistor. Okay. To construct a field effect transistor, if it is a two types, no, N channel and P channel, no. To construct N channel, we take one N channel bar. N channel bar in which a P-type material is diffused. Okay. To construct a N channel FET, we are taking a N-type bar in which we diffuse a P-type material. There is a formation of PN junction here. To connect these P together and connect a terminal called gate. Here, there is a terminal called drain. Here, terminal called source. The FET also has three terminal. What are there? Gate, drain, source. In N-channel FET, we take an N-channel bar and diffuse a B-type material. If it is a B-channel FET, we take a B-channel bar, we diffuse a N-type material and we connect these together and we take a terminal called gate. Then here drain and here source. This is why we have to construct field effect transistor. This is of construction of field effect transistor. So we are taking N channel. So in N channel we diffuse a P-type material. In a P channel we are in a P-type material we diffuse the N-type material. That N-type materials are joined together and take the K terminal. This is about construction. When you are going for a working, so the working condition initially, before going to the working, we should know the FET is working in reverse biased condition only. In a BJT working, we know that input side is always connected with the forward bias, output side is always connected with the reverse bias. At that time only, the FET working as a correctly working as an amplifier. Here, the FET always working in reverse bias only. The FET always working is reverse bias only. BJT is called a current control device. This is called voltage control device. FET is called voltage control device. So FET working in a reverse bias condition, it is called as a voltage control device. While seeing the working, we know why we call it as voltage control device. Now we are moving to the working. Initially, we are taking, this is VDS. Train, there's a connection between train source. This is called VDS. This is a connection between gate and source. This is called VGS. So initially we are taking there is no voltage applied to, after construction, there is no voltage applied to VDS and VGS. It means that both zero. Both VDS and VGS zero. That time there is no current flow. This is called channel. There is a, in this depletion layer, there is a formation of depletion layer. There is a two depletion layers are touch with each other. There is no current flow. No current flow. See here, if you are considering this is a input voltages, here input voltage. This is VGS called as input voltage. Then VDS called as output voltage. The VDS is otherwise called VDD because it is connected to the drain terminal. No, that's otherwise called VDD. Then output current. Output current is called ID because it is flow in a drain terminal. Because it flow in drain terminal. So here see the circuit connection. So input voltage is VGS and output voltage is VDS. VDS is otherwise called VDD and output current is called ID. So initially there is no current, there is no voltage. Both VDS and VGS equal to 0. That time two depletion regions are touch each other. There is no current flow. Okay. Then if you are applying some voltage to VD, so we know initially VGS, VDS otherwise called VDD equal to 0. ID, there is no current flow. Then this is initial condition. Then we are applying some voltage in the VDD. So we are giving some positive voltage like 1 volt. For example, taking 1 volt. If you are applying some voltage to that VDD, the width of the depletion layer is reduced. Here, this is the depletion layer that touch. Initially, the both depletion layer touch each other. After applying the VDD voltage, there is created some path. There is a flow of electron here. Because of the flow of electron, there is a flow of current. The electrons flow from source to drain. And already in the previous classes, I told that two types of currents are there. Conventional current, natural current. The direction of conventional current is different with that is opposite. That is opposite to electron flow. Opposite to electron flow. But in a natural current, same direction with the electron flow. Okay, here conventional current. There is a conventional current is flowing from drain to source. It means that the electrons are moving from source to drain. The conventional current is flowing in this direction. That's why the arrow is look like this. So we are applying some positive voltage. Because of that, there is a decrease in the depletion layer width. There is a movement of electrons. Because of there is a flow of current ID. Again, we are increasing that VDD to the particular, increase the value like 2 volt. Again, the current flow ID increases. The same way, we increase the, so ID increases. At a particular point, the ID will be saturated. There is no increase in the, even if you are increasing the VD value, there is no increase in the ID current value. That voltage is called VP. That VDD voltage is called a pinch off voltage. That voltage is called pinch off voltage. Okay. So initially we are making VGS and VDS 0. There is no current flow because of the depletion layers are contact with each other. There is no electron flow. That's why no current flow. Then we are applying some positive voltage in a VDD because of there is a flow of electron from source to drain. Then there is a flow of ID current. If you are increasing the VDD voltage, the current flow will be increased. So we are again in increasing the VDD value, the current flow is increasing. At a particular point, even if you are increasing the VDD value, there is no increase in the ID value. The ID value is saturated. That VDD value is called a pinch, VP. That is pinch off voltage. Then now we are applying some negative voltage to the gate terminal. Here we are applying after reaching some saturation condition. After applying saturation condition, we are applying some negative voltage here, gate to gate terminal. We are maintaining gate terminals 0. No, now we are applying some negative voltage like 1 volt. We are applying some gate negative voltage here. If you are applying some negative voltage, we are taking VGS. Already VDD reaches some VP value, that is considered as a pinch off voltage. After that, there is no increase in the current value. Now we are making VGS equal to some, already initially VGS in a 0 voltage. VGS we put in a some negative 1 volt. If we are making the VGS 1 volt negative voltage, there is an increase in the depletion layer width. It reduces the ID current flow. Then again we are increasing the VGS value as like 2 volt. Again ID value decreases. At one point, at one particular voltage point, the two depletion regions touch each other. There is no ID current flow. No current flow of ID. It means that here the input voltage VGS control the current flow ID. That's why this FET is called the voltage control device. So output current ID is controlled by the VGS value. Output current ID is controlled by the input voltage VGS. That's why this is called a voltage control device. Okay. I'm again recalling the working of FET. So for initially without any no voltage, it means that VGS, VDS, there is no voltage, it otherwise called VDD. If no voltage applied, there is no current flow, no flow of ID. So then we keep VGS equal to 0. We are increasing VDD value as some positive voltage. That time there is a flow of ID. So if you are increasing the ID, if you are increasing the VDD value, ID value also increased. In a particular point, that point is called VP. In particular point, there is no increase in the ID value. That point is called pinch off value. If you are plot the characteristic curve between, if you are plot the characteristic curve between the output voltage. What is output voltage here? VDS or VDD. If you are plotting the then output current ID. So see here, one particular VDS value. We are increasing the VDS value. One particular value, the ID value is saturated. It is maintained constant. That value is called a VP. It is this time VGS equal to 0. Okay, then we are making VGS equal to some negative voltage, because of that ID value is decreased. If you are making VGS equal to minus 2 volt, that time ID value. So like that, if you are decreasing the value, the ID value is decreased. One particular moment there is no flow of current. This is about working of field effect transistor. I recall field effect transistor is the FET is called field effect transistor. It is a uni-junction transistor. It is called a voltage control device because the input voltage controls the output current. Hence, it is called voltage control device. It has two types, N channel FET and P channel FET. We saw the working of the initially we have VGS and VDS equal to 0. There is no current flow. Then we maintain VGS equal to 0 and we increase the VDS value. There is an increase in the flow of current. If your particular time the ID current is saturated, that voltage is called VP, that is pinch off voltage. We maintain that voltage is constant VDS side. Then we make the VGS values negative, values, the ID values decrease. One particular time there is no flow in the ID current. Thank you guys. We will see in the next class, the next session we will see the power amplifier.